So let's get started. Okay, so before we get into the system about SkyPilot and CloudBank, let's take a look at what makes it difficult for a job to be run on a cloud today. So when you have a job, the first thing you want to do is to select the correct instance type for your job. For example, there are more than 3 major clouds: AWS, Google Cloud, Microsoft Azure. Each cloud can have more than 4 regions, even only in US. And we have a bunch of availability zones. Also, you may have to figure out what's the accelerator for your job. It can be A100, B100, T4 GPUs, and also there can be the number of vCPU cores, the size of the memory. There's hundreds of choices for you to choose to launch your job. After you choose your instance type, we'll now go to the Cloud Console. For example, the AWS, you will choose the region there, for example, US West 2, and you start filling out all the configurations for your instance to be launched. The instance type, disk type, the OS network setup, the SSH keys. After you fill out all the configurations, when you click on the create button, AWS may just tell you that there's no available B100 in that region at the time. So what you should do, you may either wait in the current region for a while, or just go to another region and try to fill out all the configurations again and try to launch it in another region. This availability issue is a big problem, especially recently, people are trying to train their LLM models with high-end GPUs. And it's possible that you may have to go through more than 10 regions to actually figure out there's available A100 in Asia or Europe. The remaining problem involves you have to do the data transfer for your instance. You have to copy your code and data to your VM and make sure that the data for your jobs are already on the VM. Then you have to set up the environment. You have to install your packages, your dependencies, for example, PyTorch, scikit-learn, etc. After you finally figure out or set up your instance, you now may have to submit multiple jobs to your VM, because the VM doesn't have the job scheduling system comes out of the box. You have to do them manually. For example, you can run your jobs in parallel or run your job one by one. Another problem can be that when you're trying to do distributed training or distributed computation, you may have multiple nodes, and you have to repeat all the process above again on all the nodes. For example, log into each node to do the data transfer and set up the environments and launch your job in each of the nodes. What makes the problem even worse is I believe most of our audience has multiple access to different clouds because of the CloudBank enables you to use multiple clouds to have multiple cloud accounts and the fundings from different cloud providers. And in this case, when you try to spread your spendings across different clouds, you may have different clusters on different clouds. And in order to figure out where your cluster is actually located, you may have to go to the Cloud Console of each cloud and go through all the regions to finally figure out where is your cluster. And we call the remaining problem to be infrastructure management burden. And we are building the system to solve all the problems listed here. Another problem is that the cloud costs are being more and more expensive. According to this A16Z article, we can see that $100 billion of market value is now being lost due to the huge margin of the clouds. And those are the 2 major motivations of why we build the system. Clouds are hard to use and very expensive. We built the SkyPilot system, an intercloud broker for sky computing. We try to offer the ease of use and cost savings for starting from the machine learning and data science batch jobs. Here is the example diagram of how SkyPilot is related to the user program. For example, the user program can be written in any kind of frameworks, PyTorch, TensorFlow, scikit-learn, as long as the task can be run, can be started with a bash script. I believe most of the job can be done in that way. And the job can specify a resource requirement. For example, here is 4 T4 GPUs, and SkyPilot takes all of them and go to all the clouds enabled and figure out where's the cheapest region you can launch the 4 T4 GPU instance. And it just launched the VM, set up it, and start your job. All SkyPilot will handle it automatically. Here's how it works. So how to specify the task in SkyPilot. We take an example of the ML project, for example. A typical ML project will involve a working directory, which includes the code and data of your project. There's a setup script that you can install your dependencies, like different packages. And there's a run script that you can start your program. And in SkyPilot, we just offer a very simple YAML interface where you can specify those things. For example, the work dir is the local path to your code and your data. The setup section is the script for setting up your environment, and the run section is the command to start your program. Additionally, SkyPilot provides an additional field, which is resources. In this field, the task can specify what resources it required from the cloud. Here, this task wants 4 T4 GPUs, and the only thing you need to do to launch the job is run sky launch task.yaml. And SkyPilot will just automatically pick the best cloud and region for you and provision the VM, ship the code and data there, set up the VMs, and also execute the job. So that sounds quite easy, right? So how should SkyPilot work with CloudBank then? CloudBank is a centralized place to manage cloud fundings from different cloud providers. It generates an account for each cloud for you, and the spendings will be aggregated in the CloudBank. So SkyPilot will just take the, so after the CloudBank is set up, you can go to the cloud account generated by CloudBank and download the credentials to your laptop or your server. And SkyPilot will then just automatically use those accounts from CloudBank to access the clouds. So when the user program specifies the requirement of 4 T4 GPUs, SkyPilot will just go through all the available regions in those clouds and find the cheapest location to launch your job. For example, here it is the AWS, which offers 10% cheaper cost for your job. And during the job is running, the billing will just go through the CloudBank account and be managed in one place by CloudBank. So great. So now we save 10% of your cost for running the job. Is that the end? Actually, no. So we can do even better by utilizing the spot VMs. Spot VMs is a special type of resources that are offered by many cloud providers. The spot VMs can offer 70% cost savings than the normal VMs. However, the spot VM can be interrupted and taken back by the cloud provider at any time, which means a user has to maybe sit in front of their laptop to monitor the job and recover it whenever the preemption happens. So SkyPilot ManageSpot is here to help. It is a library built on top of SkyPilot, which can automatically recover the job whenever needed. And all we need to do is to change the command from the Sky Launch we mentioned before to the Sky Spot Launch. The video on the right is the Vicuna LLM chatbot we trained before with SkyPilot ManageSpot. It is the first open source chatbot that has 90% quality of ChatGPT. And we trained the model with the SkyPilot ManageSpot, which means we can reduce the cost from $1,000 to $300. So as a research group, we are able to afford training this kind of private chatbot for ourselves. Okay, so with those cool features and libraries on top of SkyPilot, SkyPilot actually got a lot of real-world tractions. Since the first release last year, our GitHub repository has got about 30 contributors with more than 2.8K stars. Our workload spreads across ML training on TPUs and GPUs, bioinformatics jobs on Spot instances, and even war damage assessment for Ukraine. And also the Vicuna LLM chatbot we mentioned before. So to have a better sense of how SkyPilot got the traction and why it is helpful to the users, let's take a deeper look at some cases we have seen. Here is a stealth ML startup which originally ran their ML training jobs on their on-premise data center, which has 4 nodes in total. With SkyPilot, they're now able to launch the job to the cloud with 16 nodes, reducing the job running time from 2 months to 2 weeks. They also took the benefit of SkyPilot to use the multiple regions in AWS to get the best availability for GPUs and the cheapest prices. Now SkyPilot has become the core part of their cloud stack as well. Another interesting case to look at is a research group in Salk Institute, which is located in San Diego. They use SkyPilot to run their biological computation on the cloud with more than 1,000 recurrent jobs every week on large data set. SkyPilot brings them like 6 times cost savings with the Spot, and they have spent 500,000 core hours with SkyPilot already. So if you're interested of the details about how they use SkyPilot to do the analysis for whole mouse brain atlas on the cloud, please check out this blog post, and Han Qing, the researcher in Salk Institute, wrote about the details of how they do it. Cool. So since the first launch of SkyPilot, we not only see the trend for sky computing from the users, but also from the cloud providers. When SkyPilot was firstly launched, we only support the first 3 major clouds, AWS, Google Cloud, Microsoft Azure. We actually received many active helps from the cloud providers. We now additionally support IBM Cloud, Oracle Cloud, OCI, Samsung Cloud, SCP, Lambda Cloud, which is a specialized GPU cloud with very cheap GPU offerings, and also Cloudflare, which offers R2 storage service that don't charge egress costs for the users. Cool. So that's about the overview of the system. Let's switch to the terminal and see how SkyPilot can be used in your day-to-day work. I assume people can see my terminal at the moment, and cool. So let's see. The first thing we want to do is SkyCheck. Here we can see what the clouds are enabled in our local laptop. We can see AWS is enabled, Azure is enabled, GCP, Lambda, IBM, SCP, Oracle, Cloudflare. All the clouds are set up have been set up because we download the credentials to the local laptop as well already. And now, if we want to launch a GPU, for example, we want 8 A100 GPUs. We'll just type skylaunch --GPUs A108. And SkyPilot will just go through all the enabled clouds and figure out what's the offering there. As we can see in the table here, the Lambda, OCI, Azure, GCP, AWS, they all offer this 8 A100 VMs with different price. So SkyPilot will just like choose the cheapest price across all different clouds. Here it is the Lambda cloud, which has like 3 times cheaper cost than the others. So we just go there and launch the cluster. We will not launch this cluster at the moment here, but we'll try to sky launch Vicuna serve Vicuna serve.yaml. This will launch our Vicuna chatbot, which is the LM chatbot we mentioned before on a A100 GPU. To have a better sense of what's in the serve.yaml, let's take a look at the YAML file. So in this YAML file, we define the job for serving the Vicuna model. The first section is the resources, where we specify the accelerators we need, which is the A100 to run the model. The disk size, which is 1 terabyte, because the model checkpoint can be quite large. We also specify the disk tier, which means we want the high performance disk for the model, because loading the checkpoints from the disk can require a lot of I/O. Also, we have a setup section, which we specify the environment installations, including PyTorch, the repo we need, which is FastChat, which is the serving system. And also we have the Hugging Face installed underlying. We also have a run section, which we specify the commands that starts the serving program. Cool. So this is a simple YAML we use to serve the Vicuna model. And while the Vicuna serving cluster is now being launched and being set up, we can take a look at other clusters I have on my laptop. I'll try Sky Status, which is the single command that you can see all the clusters currently located on my laptop, or like launched by SkyPilot. So as I just type Sky Status, we can see there's multiple clusters listed. We have a Vicuna serve, which is the one I just launched, and SkyPilot just choose a GCP to run that Vicuna serving task. There's a workspace here. This is a GPU machine that I normally use to debug my GPU, debug my jobs that require GPUs. And it is a T4 GPU machine on AWS, and SkyPilot just choose AWS because it's cheapest for T4. And also I have, yeah.
Can I ask you a quick question? We have a question in the Q&A. So is the idea that SkyPilot is always going to look at all the clouds that are enabled and just pick the cheapest one among them?
Yes, so that's the basic usage of SkyPilot. If you have, for example, only AWS and GCP enabled, we will just look through the AWS and GCP and find the cheapest resources for you across the cloud.
Yeah, thank you. That answers the question.
Cool, thanks. Also, another thing we want to mention is SkyPilot not only choose the cheapest one, but also when the availability issue happens, for example, if we go to US West 2 on AWS and we found there's no available resources for V100, we will just automatically fill over to other regions like US East 1 or even other clouds to get you the resources you want. Cool. So yeah, so in this table, I have another dev machine, which is a CPU machine on Azure, which I usually just use for code editing and some lightweight interactive works. So when you launch a cluster with SkyPilot, you can just simply either simply SSH into the cluster. We have add the configuration of the SSH in your local laptop, so you can just use the cluster name to log into the cluster. And also, now I want to submit a job to the workspace machine, maybe a training job, and I will just type sky exec workspace and train.yaml. With that, I will just submit the training job directly to the workspace machine, and if there's enough resources, it will just start running. But if it's like there's other jobs running there, it will just queue up in the job queue, waiting for the resources. And we can see the training job is just started, and we can safely Control-C it to exit the logging. So the job will running in the background, and we can reconnect to the logs by Sky Logs workspace, and the logging of the job will just come back. Okay, so I Control C again to exit the logging. And we can also use SkyQ workspace to see all the jobs currently running on the workspace machine. And we can see here the job ID 6 is now running on the cluster. And we have several previous jobs like canceled or succeeded already. Another command I want to talk about is we have a sky auto stop -I0, which means 0 minutes and workspace cluster. So this command will auto stop your cluster after your cluster has been idle for like 0 minutes. Because now we have a job running on workspace, the cluster will keep up until the job finishes. This is very useful when you're submitting a job like during the midnight. You have a job approximately running for 4 hours, and you want to just submit the job and go to bed, but don't want the cluster to be idle for too long to waste your money. So if we now do the sky cancel workspace job ID 6, the job will be canceled on the cluster and the auto stop will be triggered. So the cluster will be automatically stopped and no additional cost will be charged to your account. So it may take a little while for the auto stop to be triggered, but if we do sky status -- refresh, it will fetch the actual cluster status from the clouds and all the clouds and give you the latest status of your cluster, so you know which cluster are up, which cluster are stopped. And here we can see the workspace is just stopped because we just canceled the task and the cluster is auto stopped by SkyPilot. Cool. So while we were talking, our Vicuna serving job has been started, and we can just click into the URL and we can see this is the chatbot we just launched on our private VM with our private model. So no one will get our input. We can chat with this model like, who are you? It will just tell us, let's see, it's Vicuna. It's a language model trained by LLCs, which is an organization in our lab. And we can ask it like, what is cloud computing? Probably it will just tell us the basic ideas of cloud computing. And it's just like a ChatGPT-like chatbot. Cool. So with SkyPilot, you can train your own chatbot and serve it with very low cost. Okay, so that's about the Vicuna serving. The final command I want to talk about is the spot launch. We have already talked about the Sky Spot, the manage spot feature. And here we will just try Sky Spot launch train.yaml. This is the YAML file we used before. Sorry, let me enlarge this window. So this train.yaml is the one we launched before to the workspace cluster, right? So we can also just submit it through the manage spot feature. So the SkyPilot will launch it on a spot cluster with like maybe 70% cost savings. And also SkyPilot will just like monitor the job, and whenever it's preempted, it will just like recover it. And we also offer a very easy way for you to just check what's the current jobs running with the spot manage spot. This is a dashboard offered by SkyPilot. We can see there are 6 jobs. There are 6 jobs we submitted before, and the job 4 and job 6 are now currently running on with managed spot. And the first one, the job 6, is running on AWS, and job 4 is now running on GCP. And they are on some regions you may not manually choose from. It's Asia Pacific and Asia, because they provide the cheapest cost for your job. Cool. So I think that's all about our terminals. Let's go back to our slides And it's closing to the end of our talk.
Can I interrupt and ask you two quick questions?
Yeah, sure, go ahead.
One is from Jonathan Scone, and it is, it does not look like SkyPilot is aimed at a hybrid burst setup integrating with on-prem. So that is, you're strictly working with the cloud. Is that accurate?
Thanks for the question. That's a great question. Actually, we start from the clouds at the beginning. We start from the 3 clouds and expand to other clouds. And we are actually considering using like integrating the on-prem into SkyPilot as well. Currently, we have a ongoing PR for Kubernetes support. So basically, we will turn your Kubernetes cluster into a cloud. So SkyPilot will treat the Kubernetes cluster as a cloud similar as AWS and GCP. So your SkyPilot job can be submitted to a Kubernetes cluster by SkyLaunch. And SkyPilot will just consider maybe the on-prem cluster is just a cloud that charges you 0 cost. And we can just like burst your job to the cloud when the on-prem cluster is full.
Cool. That's a long time dream of the community. Another question is if, let's say my institution has some enterprise agreements with cost cutting, your SkyPilot is doing the cost estimation based on API calls, right? It doesn't have special access to, let's say, cost breaks that I may have in place.
That's another good question. So we have user asking for this. So currently we do use the cloud APIs to query the official price for all the resources. And most of the cloud doesn't provide a very good API for querying the discounts contract offers. So what we do is like we have a cloud catalog API or like a file in your local laptop. You can open that cloud catalog like AWS catalog. This is just a CSV file that lists all the price for different instance types. So you can maybe apply your discount to all the instance types in that catalog, and SkyPilot will just automatically use that catalog to do the optimization.
Okay, that's amazing. Next question, could I use SkyPilot for price comparison without necessarily having a cloud bank account? And I'm telling everybody that that's correct, that SkyPilot is independent of cloud bank, and the word cloud bank is just simply advocating for SkyPilot. Is that correct?
Yeah, so SkyPilot can work with your own individual cloud accounts. As long as you bring your credentials, SkyPilot will just work. So with CloudBank, we can just, so CloudBank can aggregate all the spendings from the major 3 clouds. So you can see all your spendings in one place, but it is not necessary to be CloudBank account. Okay.
And then, thank you for clarifying that. And then the last one that I'll read you here is, has to do with upper level services that are available from cloud. So things like databases. It says, can SkyPilot compare cloud functions or their equivalents across cloud providers? Think, for example, BigQuery for GCP versus Synapse Analytics for Azure versus Redshift for AWS.
Yeah, so that's a great question. This is actually our vision for Sky Computing. We will find the compatibility layer on each cloud, like just as the example just mentioned, the BigQuery and other equivalent services on other clouds. Our vision for Sky Computing is that there will be an intercloud broker for those similar services on all the clouds, and the intercloud broker will just abstract out the interfaces for different clouds and help the user launch the job on those different services. So currently, the SkyPilot is an intercloud broker for the VMs only at the moment, but we do imagine that in the future, we will add more services into SkyPilot to support different kind of higher level services.
Yeah, so anticipating future directions, that's great. I'm going to stop asking questions to let you finish up on the slides, and then I'll see if there's some more questions that I can ask you in the time remaining. Thank you.
Great, thank you. So there's only 2 slides left, just our introduction. Our SkyPilot team now have 7 PhD students in our lab and also 2 faculties. We're very excited about making this system useful for everyone to access the clouds. And currently, SkyPilot is an intercloud broker for sky computing, and we are eager to see the emerge of the sky computing. And our main goal here now is delivering the ease of use and cost savings on the cloud, and like integrating with CloudBank, it can make the experience of using cloud even more easier. Cool. So that's all about the talk. Thank you for attending.
Yeah, thank you so much. I think it's been great to have you saying cool as you're going along, because every time you do, I'm also thinking cool. This is really amazing. Let me see, there's 2 more questions. They're multi-part, so I'll break them down. For selecting best availability, does SkyPilot also work with spot instances or only on normal on-demand instances? So I think that's, go ahead.
Yeah, so it also works for spot instances. We will just go over all the regions and cloud to figure out where's the available resources for you. Whenever preempted, we will first try the current region to see if we can get the VM back, but if it's not, we will just go to other regions and find available resources for you.
Right, so you're bouncing between different preemptible instance opportunities. And then if a job is running and then it gets preempted, does SkyPilot try and reschedule it to restart, or is there some checkpointing going on?
So currently our SkyPilot, the managed spot library is currently will only do the recovery for the job. So we will restart the job on the VMs, the newly launched VMs, and we currently rely on the checkpointing of the user program itself. For example, we offer a convenient feature that you can mount a bucket onto your VM. So in your task specification, you can mount a bucket onto your VM, and you can write your checkpoints as you are writing to a normal disk directory. So during your training, you may checkpoint your program, checkpoint your training model every 1 epoch or several iterations to that folder. And whenever it's preempted and recovered on other VMs, you can just load the latest checkpoint from the folder and continue the training.
So if I'm saving my checkpoint to object storage on AWS and then it gets preempted and you bounce me over to Azure, does SkyPilot bring the checkpointing data along for the ride?
Yes, so we will still mount the AWS, the S3 bucket to the Azure VM, and you can just read the data from there. There will be a little bit of data egress cost, but since the model checkpoints is not that large, it's just ignorable to the computation. Yeah.
Okay, cool. And then let's see, this person says, I tried to use SkyPilot last month and attempted to launch A100 × 8 spot on AWS, and it is in pending status for preemptible instances for more than 24 hours. Wondering if it implies the spot instances for 8 A100s are not available on EC2 for that 24 hours. And if I added GCP Azure, will SkyPilot detect those instances better?
Yes, so that's a great question. Actually, 8 A100 is a very hard to get resources on AWS at the moment. We have seen, when we are trying to train the Vicuna model, we can never get A100 on AWS, maybe because they're out of capacity or so many people are training LLM on AWS. So we do see that GCP has better availability for A100, and SkyPilot, if you add the GCP and Azure into the enabled clouds, SkyPilot will just fail over to those clouds to find out the available resource for you.
Cool. CJ Keist asks, can SkyPilot be used in a shared server instance, or is it expected to be installed on each user system?
Yeah, so currently SkyPilot is working as a library. So it's like you have to install it on your individual laptop, and your clusters will be, so the clusters launched by SkyPilot will be your own. So you can have a server that's shared by many people, and the SkyPilot can be shared by multiple users, but currently we're focusing on individual user at the moment.
Okay, cool. Let's see, we still have a couple of minutes. This is great. Jonathan Scone writes, you use the adjective sky computing because there is something distinguishing from cloud computing? I would answer this by saying sky is a brilliant name because lots of different clouds float around in one sky.
Yeah.
Is that fair?
Yeah, exactly. So we are seeing many clouds emerging. Like there are 3 major clouds: AWS, Azure, GCP. And there are, as we just mentioned, there are more clouds coming, like IBM, Samsung, or even like smaller ones like the Lambda clouds we just mentioned. So we imagine that in the future, there are more clouds coming up, and we're kind of like doing the sky, we're being the sky, like having all the clouds in a whole, in our single system, that people don't need to worry about the interface difference between different clouds. They just specify their job and we will run it on any cloud for you.
Yeah, fantastic. And then this is kind of some material that we've covered, but we're covering things that are really high speed. And I want to ask this question, but first I want to ask one of my own, which is, let's say I watch this webinar and I'm really excited. How do I go about learning to do the details? Where's the user manual?
Cool. So one way you can get to it is like there's a skypilot.co. We link that URL to our GitHub repo, and there's a simple README there, and also there's a document link. If you click into it, there will be a whole documentation for how you get started with SkyPilot, set up your credentials, and how to launch a job there.
Okay, so if I just do the obvious thing on search for SkyPilot, I'm going to find it right away, and it'll just walk me down the garden path. Okay, right. Here's the question I wanted to repeat. If checkpointing, does that mean I must have some sort of storage? How is the checkpoint written and how often? And wouldn't that be an additional cost?
That's a great question. So as we just mentioned, you can mount a bucket to your VM. This is natively supported by SkyPilot. SkyPilot will automatically create that bucket for you. For S3, for example, it's very cheap comparing to the GPU instance you used. Even if you're saving the checkpoint like frequently, it's really cheap for storing the data or writing the data to that bucket. It will degrade a little bit for your training speed because you have to save the checkpoints maybe every 30 minutes or every 1 hour. But it's just worth it because you can now save 3x the cost comparing to using a normal instance. And saving checkpoints is actually the thing you have to do even without SkyPilot. And if you want to use the spot instances, you still have to do the checkpointing yourself.
Right on. Okay, great. Bob Flynn has helpfully added a link into the Q&A pointing to something called Sky Computing, the next era after cloud computing. So we can go take a look at that at our leisure. And then the last question that I'm seeing here, and maybe we can call this the last one for today, is a follow-up on GCP, Azure, AWS Spot instance. So will SkyPilot actually know how many instances are available and give some estimation on the capacity of these different clouds? Will SkyPilot expose this information to the users in the future? And And then they remark, currently I am just seeing pending and wondering if you can let me know something more, like there's nothing going on or whatever. So sort of digging under the feedback that you're getting from the Sky system as you're running it.
That's a good question. So currently SkyPilot is just rely on try to create an instance there and see if it's success or not, and just go through. If it fails, we will just like fail over to the other regions. Because most of the cloud currently doesn't offer any kind of APIs for you to query about the capacity of the resources. Mainly, we are guessing that mainly because the commercial reasons, like they don't want to show the users what's the demands and what's the supplies in the cloud. But one thing we are currently thinking about is we can probably offer some kind of availability information when we have when we collect all the usages from our users anonymously. We can have a kind of Google map that aggregates the user feedbacks, user experience on one road, whether it's congested or not, and we will have that information and maybe show our users in the future.